6 at the top. When we are multiplying and the base is the same, the base stays the same and the exponents get added together. Okay. To demonstrate why, if we have a cubed times a to the 4th, then we have 3 a's multiplied together for a to the 3rd, 4 a's multiplied together for a to the 4th, which gives us a total of 7 a's multiplied together. So we add the exponents together. That is the rule. That's it. Okay. So, look there at 17. We are multiplying. This stays as a 4. But what's the new exponent? This is 4 to the 11th. I'm not going to make you put that in your calculator. Okay. Matthew, how do we get 11? Add the exponents. 3 plus 8. Number 18. We're multiplying. The base is -7. It stays -7. But what does our exponent become? 9. 4 plus 5 is 9. If we have a negative base, there needs to be parentheses there. Yeah. Yes. However, we're saying that we're multiplying -7 9 times. So the answer, if we put this in our calculator, yes, it will be negative, okay? But we aren't actually multiplying -7 and -7 together. We're just rewriting it as -7 to 1 power, okay? Look at number 19. Ooh, 2 to the -6 times 2 squared. This becomes 2 to what power? What's -6 plus 2? -4. Are you allowed to leave negative exponents in your answer? No, you are not. A negative exponent has to be rewritten with that negative exponent crossing the fraction bar. Huh? Are you whining? Okay. You're not going to be ready. Okay. Now, I think it is easier when we have variables as our bases. Okay. Look at 23. This becomes x to the what power? 7. We're multiplying, so we need to add our exponents. Done. Okay. We add our exponents here. What do we get? Oh, m squared. We're done. Now, 25 is interesting because what happens when we add -7 plus 7? We get 0, and k to the 0 is not an answer you can leave because k to the 0, anything to the 0 equals what? Equals 1. Okay, now 26. What numbers am I adding together? Just 3 and -9? And 1. This is an a to the first. Okay? If the exponent is 1, they're not going to write it. But we know that it's there. So when we add 1 plus 3 plus negative 9, what is our exponent? Negative 5? Yeah. Okay. Landon, do we leave our answer like that? No, we cannot leave a negative exponent. Okay, negative exponents have to be rewritten. If you're not writing this down, you are not meeting my expectations. If you're not writing this down, it's really going to stink for you when you do your homework. Okay. Now, I want to skip to number 28. Number 28, we have 2 different variables. Does that matter? No, we're going to multiply our r's together. We're going to multiply our s's together. So when we multiply, I like to be alphabetical. That's just a weird thing that I have. If we multiply our r's together, what is our new exponent? Negative 6. If we multiply our s's together, okay, remember if you don't see an exponent, we know that there's a 1 there. So this is s to the negative, or to the positive 2, excuse me. Now, we know that a negative exponent needs to get sent to the denominator. So I'm going to save you some time. Do you like a time saver? The positive exponent stays. Make your fraction. The negative exponent goes to the denominator. So instead of like writing this out and then multiplying, I'm just saying, okay, the positive 1 stays and the negative gets sent downstairs. So we have just 1 fraction for our answer. What? If they're both negative, then they both get sent. So I think that happens in your homework. So if this was like a to the negative 2, b to the negative 3, you would write 1 over a squared b cubed. Okay, that's a good question. Thank you. Okay. Now, this is all fine and dandy until we throw some coefficients in there. Okay. Coefficients, the number in front of the variable. You have been multiplying coefficients since elementary school. You know how to multiply numbers. What do we do, or what do we get when we take 4 times 2? Yes, the coefficients get the normal operations. Okay. But then a to the 7th times a cubed would be a to the what? 10th. So there's our answer. Our coefficients get multiplied like normal. Then, if we're multiplying and we have exponents, we have to do that rule. Yes.
You said 9. You said 9.
Okay, write down what you think the answer is for number 30. Jacob, what do we get when we multiply the coefficients? Negative 15. 5 times negative 3 is negative 15. And then m's, what's the exponent for our new m? 3, because this is m to the first, this is m to the second, so we add them together. Now, do we have any negative exponents? No, I know you see a negative, but that negative is our coefficient. That is okay. This is your answer. Okay. Okay, look at number 32. Okay, so here, what numbers are we multiplying for the coefficient? 8 times.
2 times 1.
Oh, thank you. This is a 1 right there. So what is 8 times 2 times 1? That's 16. Now, when we look at our exponents, -5, -1, and this exponent is 1. When we add those together, what do we get? We get -5. Now, here's where we need to be careful when we rewrite our answer, okay? The -5 belongs to who? It only belongs to the p. It does not belong to the 16. So when we rewrite this, the 16 stays. It does not have a negative exponent. Only the p has a negative exponent. Okay, one more problem and then I'll let you loose on your homework, okay? I just want to look at number 33 because there's more than one variable. Our rules don't change. What are we going to do with this -2 and this 6? We need to times them. -2 times 6 is -12. The coefficient always gets the normal operation, okay? But for the a and the b, if I have a times a squared, it becomes a to the 3rd. If I have b times b cubed, it becomes b to the 4th. If there's no exponent, we know that there's a 1 right there, okay? The negative is with the 12, but it's not an exponent. It's just a negative coefficient. There's nothing to move there, okay? So if you turn to page 7, you should have already done 1 through 11. I'm asking you to do 12 through 26. I won't even make you do the last 2 on the page. I just want 12 through 26. Okay? I will start putting answers on the board for you to check your answer. I need you to make sure that we're getting the right answer before you head home on the weekend.